Okay, I think you can see the screen, right?
Yes, sir.
Okay, sorry. So uh, what we are discussing that if we have got a phone class definition, if you have got a vehicle class definition and account class definition, and we can using that we can have a person class definition also, where a person class is composed of an account, a phone, a vehicle, some ID, some department name, whatever. And it will also have some behaviors like make, call, drive, draw, like that. And if we consider that these are the instances corresponding to uh, say, so phone is a class now, because it's like that, phone is a class, vehicle is a class. So P is an instance of phone type, V is an instance of vehicle type. So using that, say make a phone call, so P dot make a phone call. Vehicle, if you would like to start driving, so V dot start drive. Access an account, if the instance of that account is identified by A, so A dot this, like this. So I'll not focus on the syntax right now. So that is how, what I mean to say is, if we have identified some entities, if we can find out some common entities or the entities which has got some common behavior and characteristics, we can come up with a definition like this. And we can when we come up when we try to define a new class, I would like to see that whether that class definition can use some existing definitions. Are you getting my point? That means if I would like to define the person class is using the definition of the phone class, account class, and the vehicle class. Is that fine?
Yes,
Yes,
sir.
sir.
So in other words, if I say that this is a if I say that this is a person class, you see, so say if this is a person class, and if this is a vehicle class, account class, and a phone class. So first, say you have defined these three, and then you are trying to define this out of this. So how do you think that these three classes are related to the person class? What can be the I mean, in better terms, we can say how they are related. What kind of relationship exists between these two classes, these two class definitions? We can say a person has a phone, a person has a vehicle, a person has an account, right? Do you agree with this?
Yes, sir.
Yes,
Yes,
sir.
sir.
So it's a has a kind of relation, right? And this is a standard terminology. It's not just like I'm speaking out this. So this is indeed identified, or actually terminated as has a kind of relationship. So can you see that the way the design is going on? So earlier we just focused on identifying methods or procedures or functions, that's all, and somehow try to minimize the coupling and increase the cohesion, that's all, in a top down fashion. But now we are trying to basically identify entities, finding out common entities, and coming up with a definition which we call it as a class definition, which actually is meant for all the similar entities. And when we are trying to find out a class definition, we would first look for some existing definitions, if there is any, which we can use. In this case, a person class or a person entity uh, will be having a phone, a vehicle, or an account. So basically the person class definition also will be using in some form the existing classes phone, vehicle, and account. And this kind of relationship that these two classes or these four classes are having, they basically are having a has a kind of relationship, right? So this feature is also called uh, do you know, anybody knows the name of it? Has a kind of relationship in C++ or in Java. What is it better known as? Any idea?
Inheritance.
Inheritance.
No, not inheritance. Anything else? Any idea? Those who
Compo
have, yes. Hello?
Self.
Hmm?
Self.
No. Those who have worked with Java, I think many of you have worked with Java and C++. So you should have have you heard about composition?
No, sir.
So composition, you see, you can say that the person class is composed of account, vehicle, and phone class, right? Or I mean phone objects. Can we say that? So how do we
Yes, sir.
state it? So a person class entity,
Yes, sir.
person class entity is composed of an account entity, then a vehicle entity, and a phone entity. Do you agree with this in words? Can we say that?
Yes, sir.
So that is in real world. So you don't need to know any programming or anything else, any design. So it's any layman will say that, okay, yeah, person composed of like this. But it also is composed of many other things like the ID, say other ID or whatever. So other also you can say that other is a class which includes the biometric, your other ID, your address, your phone number, and all this. So that way it goes on. So that is how that the design is getting changed. Now you are trying to define a class always in terms of some existing classes, and you try to find out what kind of relation those existing classes, if any, is having with this new one, right? So this is one type of relation that they have. It is called composition type, and that is often known as has a kind of relationship. Is that okay?
Yes, sir.
And a specific entity of that class is known as what we mentioned. I think all are
Object.
removed. That is known as object. Okay. So now, so this is how it is actually shown. So when we show it, we show it like this. So using this symbol. So this is a person is having a phone, person is having like that. So that is a notation. There are other notations also in object oriented design. So as we come up with flowcharts, so this is also when we deal with object-oriented languages and object-oriented designs, you will be given with such designs, and as a programmer, you have to implement those designs in terms of coding syntax and all this. So once you know the design, it's pretty trivial to write the code for it. But the design is important. How you identify the the classes, how you identify the relationships, how you identify the characteristics, behaviors, and all this. Okay. So now let us come to the other case. Like you have got a phone now. You are happy with that. You have submitted your software, you have designed it, and everything was running fine. Now maybe with time you find that there are too many functionalities that is getting added to a phone class, right? Because these days are we using purely phones? Probably not. So phones, you see, you can even write codes also in the phones. You can browse internets, you can use it as a storage unit, you can use it as a camera. So there are many multiple uses of phones. So those are basically smartphones, right? So phones are not just capable of making phone calls, receive calls, and receive messages and sending messages. They are far beyond that. So we can say that uh, in this case, created some space anyway. So okay. So what we have, if we have got a phone type, we know that we have got a phone class, and which has got those three or four. But now, as the list of capabilities or behavior getting gets enhanced, and maybe you are having some new features also, new attributes also, like we are having touch. So earlier it was like keypads. Now you have got touch pads. So whenever, in addition to this, whenever you are having something else like touch pads, like that is a new feature or new characteristic. So there are phones these days which, in addition to having all these, okay, they are having this feature also, a newly added feature. Or there are, in addition to these four, they are having additional features. Maybe I can write it in blue. So what are those? You can now take photographs. You can then use it as a cloud storage, and you can write codes. Then you can play songs and all this. Browse internet. So for this, you need not have to have a laptop or a desktop. In the phones itself. So now we call it as, so these are enhanced. So this phone that was earlier defined, maybe it was defined keeping in mind the type of phones we used to have in 2000 and 2002. But now if you try to encode a phone, it will be like this. So it is not like you discard this entire definition, rather you basically try to enhance the definition of a phone and try to include few things like touchpads and these capabilities with it, right? So now what it becomes now, this becomes a smartphone, right? So now can we call it as that phone was a class? Can we call it that phone was a class and smartphone is also a class? Now can you say that how these two, so do you agree with this? Phone is a class and smartphone is a class.
Yes, sir.
Yes, sir.
Are they same?
No.
Definitely not, because maybe that there is a person who is not so rich and he's still using that same phone which is having keypads, right? A small phone, Nokia phones of like 800, 900 rupees. So that's still there. But you are always having many more of us who are using smartphones, right? So you have to have both of it. So if both of us are there, and you are insisting in enhancing the definition of that phone class, so you would like to have something like smartphone, which is which has got many additional features, not only just touchpad, but also a camera. And there are multiple cameras these days. You'll have a cards and all. So say storage cards and all this. Okay, so there are so many things got added here, and so many behaviors that also got added here. But these two are there. So can you say that how they are related? If I would like to do it, so but the smartphone has got many things similar to that of a phone, and in fact a smartphone got uh, mm, you know uh, you have got you have added something to this phone class. So how these two can be related? What can be the best way to define it? How they are related?
Is a relation. Smartphone is a
Easy.
phone.
So smartphone, basically we can say it's ISA, because that is also in English also like that. Smartphone is a phone, right? Then you can also say that okay, a land phone also is a phone. Maybe in our HOD's room or in the director's office, you can still have a land phone. I don't know whether anybody uses it, but this they still exist. We have got landline numbers and all. But land phone is also a phone, right? Because they're all phones. Are you getting the point?
Yes, sir.
So now you see phone is a class, smartphone is a class, land phone is also a class. Now maybe that as a client I just ask that okay, we have so many phones, or maybe as a designer you find that it is really difficult to have say those maintain in your database those sophisticated phones having a lot of characteristics and behavior, along with those low cost phones which are almost having nothing. So how to do it, deal with it? So you say that let us have both the classes coexist together. And when I'm trying to uh, write this class definition, I can derive it from this. So a smartphone class can be derived from a phone class. So what we say is a smartphone class definition is derived from a phone class definition, phone class, right? Why? Because as smartphone is a phone, That is also a phone, right? So this is a phone. So we call it is a relationship. This is a relationship. So earlier what we discussed about that relation, it was a earlier one, it was a
Has
has a
a
relation,
Has a
right?
relation.
And this one is a this
Is
is
a relation.
this is a relation. Is a relation. Is like this. And now this sum and what is this technically called? That was called composition. And what is this called?
Inheritance.
Hmm?
Inheritance.
Inheritance. And why it is called inheritance? Also there are reasons, because you see, say if you think of that, your father, he has got maybe uh, he has got a house, or I mean from your father you have inherited a house. So he had built a house for you, maybe a car. Okay, so that is also there. And then maybe something else he has given, maybe some bank accounts and all this. So this was what your father had. Now uh, as his son or daughter, so you'll be having this. So thing is, now you are trying to define your property. So then your property means you can default assume that you will be inheriting everything, right? So you will have this house, then this bank account, and then the car, right? But you can also have, say, instead of having only this car, you can have some other things also added to it, right? So you can have one more car, or you can have something else added to it. So you can have a laptop which your father or a desktop which your father didn't have. So having whatever it was with your father, you added few things more to it. So when you are trying to define your property, you basically say that your definition of your property can be inherited from your father's property, right? So that's why uh, the term inheritance came. And as if this existed prior, and then when the demand for this one came, which is a specific type of that phone type, so you basically inherit the definition of this class to this, but add few more also. Or you may think of that, I'll just upgrade this car to a more to a smart car. So it was an ordinary car of like 1990, and I will upgrade it to a smart car, add new features to it. It was a single story building, I'll elevate it to a 3-story building, like that. So you can keep them intact, you can modify them, you can add something of your own. So can you see that uh, uh, like in a normal sense also, you are trying to inherit something from your father's property, and you are trying to add something of your own. So the way in this case also the smartphone class is defined, it inherited all the characteristics and behavior of the phone, and it added some of its own, like this. And may have so these days, do you have any keypad type? Keypad, we always have touchpads. So the keypad which was here, it will be missing here. So the keypad is completely missing. So you can do all these changes. So the thing is, when you are trying to come up with a new class definition, you can, if there is a kind of relation, so you can copy it, then remove few things, you can add few things, and you can come up with a uh, completely new definition. But once it happens, then you can say that it has got a kind of relation. Is that fine?
Yes, sir.
So to
Yes.
summarize, in a object oriented design, you may have multiple class definitions, and those classes may or may not be related to each other. If they are related to each other, they will be either related in a in form of is a relationship, or in form of has a relationship. Is that fine? So now, just before
Yes, sir.
I wrap it up, so if I say this is person, and you have got the phone, the vehicle, the account. So now initially your perception was like that to model the system, So these classes we have defined. So how they are related? What kind of relation it has got?
Has
Has a relation.
Has a. So it's a has a relation. Now it was fine, the software was working fine, but now you find that now these days people are having so many variety of phones and it becomes really complicated. So if a person is carrying just a very small phone, so there is no point of having so many attributes that would have been required for a smartphone, right? So you really have to distinguish. So whenever you have got so many entities here within this class which are again distinguishable, right? Like all are persons, but among all these persons, now you know that okay, it becomes too complicated to model, too complicated to, to model staff, then a particular student as well as a faculty, right? Because the staff is not going to take a class, a student is not going to earn salary, right? So there are differences. So all the persons are not the same. So to me, I would like to distinguish. So if I would like to distinguish, then what you do? So you can create a staff class, you can create a student class, and you can create a uh, uh, faculty class, right? So now how do you think that they will be related to the person class?
Is a relation.
Because staff is a person, right? Student is a person and faculty is a person. So these are specializations of it, right? Because you know that the now there are, so they are all persons, but they have got distinguishable staffs, they have got distinguishable features or features which is distinguishable from the students and from the faculty. So why don't I just categorize them differently, and once I decide, I this person class is there because they are all persons, so they will have always have Aadhaar card ID, and then voter card ID, and then address and all this, uh, so the gender, age, and all this. But apart from that, whether we're drawing salary or not, that will be there in the faculty and staff. You are having marks or not, CGP and all these related to students and like that. So that is what we mean. Whenever we have phones, now we know that there can be say land phones, there can be smartphones, like that. So then land phone is a smartphone. So in vehicles also, what do you think? So there can be two-wheelers, there can be four-wheelers, right? Do you agree with this? So this is again a is a relation. Hello, is that fine?
Yes,
Yes,
sir.
sir.
And now these days you can have smart cars also. Although in our country, smart cars or auto driving or self-driving cars, like that. So you can think that these are smart cars, four-wheelers, but these are smart cars. So smart car is a four-wheeler, and a four-wheeler is a vehicle, and a two-wheeler is also a vehicle, like that. An account, what can be the specific types of that?
Savings,
And
current.
current account. So probably we are not interested in current accounts, but the businessmen, or they are more interested in current accounts and all this, right? So that is how the whole thing gets. So uh, can you see the class diagram here?
Yes, sir.
So how many classes are there in this class diagram? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 classes, right?
14.
But initially, what we started with, only 4 classes: person, phone, account, and vehicle. Now, with time, as things becomes, more complicated, or maybe the customer demands are like you have to specify or characterize them. You then either so you create more classes, but when you create more classes, you would like to link it with the existing class hierarchy, either through has a or is a relation. So there are two things. So either it is ISA, means it's a kind of inheritance. So inheritance is modeled using a, or ISA is modeled in terms of inheritance, and has a means you are modeling it as a composition, right? So what is this? This is object oriented. What is this? Object oriented design. So you see the design is completely changed now. Now when you are writing the code, so you basically implement the person code first. So first you implement these components of phone, vehicle, and account, and then you write the person class where you create an instance of a phone and all this, and keep on doing that like that. So the actual syntax we'll definitely see later on. But are you getting the design, the change in the design, and the change in the way you think how to model the real world problem or scenario?
Yes,
Yes,
sir.
sir.
So
Yes,
yeah,
sir.
and so basically we'll be in details we'll be talking about inheritance and composition and what exactly this is, not in this superficial way, but this is macro level perspective of how the design gets changed, how in the object oriented design. So you will be given with such things. So whenever you are trying to write something in C++ or Java or Python or something like that, so you'll be given with such designs, and you will be then asking, okay, so can you just give me the details of this person class? What are the attributes and the behavior for this phone class? What are the attributes, behavior? And once you know that, it's pretty simple. So you just declare data structures for the attributes or the characteristics and write functions or modules for implementing the behavior. That's all. Is that okay?
Yes, sir.
Yes, sir.
Okay, so just to sum it up, so before I uh, sum it up, so the real world consists of identifiable, classifiable, and interacting set of items. Do you agree with this?
Yes, sir.
And why interacting? Because you see the person is so this is what interaction means here. You see, when you yeah, so this person is making a phone call, so it is interacting with a phone object. So this P is a phone object. It's an instance of a phone. So P is a phone object. So the person is interacting with this phone object by invoking its behavior, right? So this is what interaction means. Are you getting the point?
Yes, sir.
Yes,
The
sir.
person is interacting with the vehicle instance V by invoking its method, say start drive, provided these are made accessible. So whether it is accessible or not here, that is another issue. So we will look into it later on, because if you have made everything private to you, so they are not accessible from this. So those issues are there, but again that is how it is done. So the thing is, each item is having identifiable characteristics, that is a set of attributes, and also having well defined behavior, that is a set of functionalities or capabilities. Do you agree with these two? Each item means each entity within that class. Agree with these two lines?
Yes, yes, sir.
All items
Yes.
having the same behavior are grouped under a category called a class. That's also fine.
Yes, sir.
That's important. State of an item is determined by the values assigned to its attributes, because all vehicles will have some color and all this. So say some i20 white color, i20 red color. So these are two different items. So how we distinguish between two entities? By assigning a value. So what is the state means? So today it's my white color car, so after 6 months I make it black. So that means the state of that entity, of that object. My car is an object of the car class. So by changing its color from white to black, I basically change the state of the object. Are you getting the point?
Yes, sir.
Sir.
Yes. So state of an item is determined by the values assigned to its attributes. And in fact, through some behaviors, so when we invoke some behaviors, those behaviors might make a change in the state of the object. Okay. So again, these are a bit technical, but again, these are trivial things, nothing too much to understand. So some attributes and behavior may not be accessible to others if they are labeled as private, outside the scope of that item, whereas remaining ones may be accessible to others, that is to anybody outside, that is if they are labeled as public. So in fact, private and public, these are the scopes that you can tag while you define a particular attribute or behavior, right? Are you getting my point?
Yes, sir.
So might be that as a person, you would like to hide your bank account number, but you may be willing to share your roll number. That's all. In terms of behavior, you would like to hide some of your behaviors, but you may reveal some others. So like that. Different classes may be related to other classes in the following way. Either they are unrelated, that is always possible. Like the tree, if I have got a tree here in the same hierarchy, so tree is this. So tree has got another kind of hierarchy like this, but tree is not related to any of these. I believe that the trees are not personalized. So they are, so I mean, tree means what? So those trees that we have drawn in that figure. So these are the trees. Okay. So that tree is not related to this. So they may be either unrelated or they exhibit a has a relationship or a is a relationship. They can be either, so multiple classes, they can be related, unrelated, has a or is a. So is there any other possibility?
No.
Hello?
No,
sir.
sir.
Okay. And any two items may interact with each other by invoking their behavior. That's all. So finally, this real world identifiable, classifiable, interacting set of items, these are called objects in object. So in object oriented terminology, these are called objects. These identifiable characteristics are basically the data variables. Their behavior is basically the implemented in forms of methods and functions. The objects having same behavior are grouped under the same category called a class, and the definition of a class actually, so this is encapsulation. So combining these two together, when you define a class, in a class definition, you have to combine both of these together, right? And that combining both data variables and methods is basically called encapsulation, because you are binding both of them together. You are putting in the same bag, you are putting the data as well as the methods, like, so that is what encapsulation means. You encapsulate both of them. Then this private or public, and in fact one more we also mentioned, that was protected. So those are all access specifiers, which is meant for having more control over data and methods. So you are giving more control, access control over the data. And has a relationships is better known as composition, is a relationship better known as inheritance, and two objects may interact with each other. This is better known in object oriented terminology as message passing. Is that fine?
Yes, sir.
Yes, sir.
Okay, so I'll end up the class today, and there are a few slides I think that we can continue in the next class. This is why we learn or focus on C++, because still it has got a decent market share in terms of the softwares that still run or use C++, even in research or even industrial research, or because it has got several other advantages. Okay, this is the man who actually invented C++. So we'll talk about that story, Brian Stroustrup. And this was a photograph taken 20 years back, but when he invented it was long back. So when he invented that in 90s, okay. So it was in even in mid 80s. So whatever he thought of, I like it's not only the syntax, but also how the object-oriented philosophy can be implemented. It was he wrote the first C++ compiler in 1985, then which later on modified, and different developers, they modified it and all this, and still it is in use. So as you can see that almost like 80, so 20, 30, 35, so more than 3-4 decades it's spanning and still relevant these days. So, and it was, so I found it from the Wikipedia that he just wrote it out of facing problems in dealing with C. So he faced some problems and thought of making some changes, keeping the syntax of C intact, and that's how C++ came. So it's more like C, but having all the object-oriented features put together. Okay. So we'll look into this later on. Okay. Do you have any more questions?